Today I'm going to show you how you can run a geo test using the Google Match Market, which is using a time-based regression. The great thing is that you don't need to be a data scientist. I will share with you the notebooks and I will give you everything that you need to be able to run it yourself. So first I want to go through what is a geo test, why do we use geo test as a solution, and then why time-based regression makes sense in that scenario. What you're going to see is that a lot of incremental and geo test vendors are asking you because everybody's using more or less the same framework. If you Google Match Markets GitHub, you'll end up with the homepage of Google, which is great because you have a lot of information about the system. You have a lot of papers. Unfortunately, the papers are scientific papers, so they're not overly exciting to read, but to get into the detail. And yeah, let's start with this. Everything is in Colab, so you don't need to have Python installed on your computer. You can just use your Google email address, open a Colab notebook that I'm going to share with you, and then you can just run it on your side. So first I want to go into why a geo test. What we do in a geo test is that we pick a treatment and a control group. And the great thing about geo test is that it controls for seasonality and some noise, because you have geo test and then you have the pre-post test. Usually what I like to do is to do the both at the same time. And so if the both say the same thing, I'm very happy. If one of them say opposite things, then I think it's worth diving into it. Doesn't always mean that the test is invalid, but I like to have the pre-post and the geo test ticking the boxes. The geo test, as I explained, is a bit more robust in the way, for example, if you have Black Friday, you're going to have a control over the two geos. About this, if you do a pre-post, you're going to see that massive spike on Black Friday during the treatment, and you're going to think that mathematically the treatment increase in revenue will be applied to the treatment group, which is incorrect in a pre-post test because of seasonality. So geo makes the difference with that. It means that on both sides you should see the jump. Now, it's not perfect neither, because you can have, for example, a specific event happening in a specific geo. It can be a competitor event. It can be a hazard like a massive fires in California, for example. It can be plenty of things. So the geo is not completely robust neither, but it's definitely a step forward, and it's a bit more complex and a bit more robust than just a pre-post test. And so what we do is that we compare the treatment and the control, and we try to define what is the lift within a confidence interval. Why TRB is better than an A/B test? So it does adjust for pre-existing difference. So for example, if both are trading slightly different, the time-based regression will be able to pick that. While if you just do a simple A/B and you compare the two groups of geos, you will not necessarily pick that. It handles seasonality and shocks a bit better than just an A/B because it predicts a daily counterfactual. And then also it's a bit more robust when you do imperfect randomization. Because it controls better the noise, well, theoretically, it's also better when you have big imbalance between the different groups. So if you go on the website, you'll have on the bottom, you scroll down on the GitHub, you'll have two links, the design and match market geo experiment and then the post analysis. Now what we're going to do is that we're going to open the notebook, design and match market and TRB. It's going to be mine that we're going to open. I've done a few changes because there's a few things that we needed to update in the Google Notebook. I sent a PR on Google, but when you're watching that video, that PR is maybe not approved or merged yet. So I will share in the bottom of the video my design for the TBR that you can download. So now we are in the design of an experiment with TBR using Match Market. So the way a notebook works when you open like this is that you have all of those cell here. What is great with notebook that Colab is that you can write a lot of comments. You'll see that there's even my own comments, but you run the cells one by one. So I'm going to press play here for the first one. What this one's going to do is that it's going to install all the dependencies that we need. And then we have to wait. Okay, done. So a few of my notes here. It's always best to have the spend by geo, but not. Yes, we'll talk about that. You'll better understand what I mean when I go into the data. But what is important is that it's the thing that is on the right here. This is just the code. If you reopen the notebook, you're not going to see the code. You're just going to see what you see on the right here. So you have a link to put the sales table and then the geo eligibility table. And now I'm going to move to first my geodata demo to show you how it looks like. So we have the date, we have the geo, we have the response, which can be, most of the time it's revenue, but it can be units, and then you have the cost. Now, if you ever run a geo test, you know how it is almost impossible to have spend by geo unless you spend on Meta and Google. Meta and Google are great, but all the other channel, it's always a bit challenging to get the spend by geo. So it's a bit of an utopia to expect to have the spend by geo, which is a bit of an issue with the meridian of Google. Personally, what I think personally. So the way I usually do it then is that I look at the overall ROI and I apply the overall ROI to the response, and I define the cost. So it's kind of a normalized cost. It's not perfect, but usually it's close to the reality because your channel will optimize to maximize revenue over spend, right? So normally the ROI across the country by geo should be more or less the same. It's not completely true. I do see sometimes difference, but the difference I've never seen a difference above 20%, for example. So it can happen. So this is how I define my cost. And then we have also the demo eligibility. So we're in the demo eligibility table now, which is great because you can decide if you want a specific geo to be in a control, in a treatment, or you want simply to exclude them. So that means that we're going to use greedy search later to create the split. But that means that if you don't want to use a greedy search and you just want to run and understand what is the feasibility of the test, you can just you can just select in which group you want each geo to be and go with this. You can also exclude. Why would you exclude a geo? Well, there's many reasons why you want to exclude a geo. For example, if you have shops and you just open a shop in a geo, that can impact the relationship between the two groups. If you have a fire hazard, as I explained earlier, if there was a specific event in a geo that can break a bit the relationship, it's always important to consider maybe to exclude them. Another reason why you simply want to exclude is coming to my mind now is that, for example, what I do in the US and I split the country in two, and so I have two region where I can run tests. And I said this, but the country is not split east-west, it's split across to be representative. And so then, for example, if you want to run the geo in a specific group, you can just exclude it here this way too. And once you've settled your two table, you add your table here, you put the link of the Google Doc, and then you run it. When, I'm not sure I explained this, but you saw that little round and then that it's ticked, it means that it's run. So we can go next. Now that we have inserted the table, we're going through a bit of data here. So the minimal detectable incremental ROAS. So it's really the minimal detectable incremental ROAS you're happy with. So it's really a business decision based on like what is your margin, etc. But here in my case, for example, I had an average ROAS of 8 in the sheet I created, and I set my minimal detectable ROAS as 6. For example, you should not lose money by selling, correct? So that's should be your minimal detectable incremental ROAS. Below that, you're not interested. That's one of the issues, that you have that diminishing return curve that can happen. And that's one of the main issues you have with Geo Test. And that's an issue with smaller channels because there's so much noise because you have the big channels and then you're testing a smaller channel. And then you have to push a channel so hard to be able to create that signal out of the noise to be able to find that incremental lift, that at that level, it's not really interesting to spend anymore. That's usually something I see quite regularly. And so minimal detectable ROAS will be the ROAS minimum ROAS I'm happy with. Average order value, it's 1 if it's dollars, or it's a dollar value if you want to work with units. Confidence level 90, power level 80. That's like the basic numbers that we use in the industry. Experiment duration 4 weeks. That's usually the periods. It will depend on mainly on your consideration journey. So if your consideration journey is much longer, it's recommended to have a high duration. Also, a longer duration can help you to detect a small lift. If you're stuck with a budget, if you need a massive lift to be able to see something, then you can increase the duration. But increasing the duration comes with a few caveats too. One is that there's going to be seasonal elements, the market can shift. Also, it means that you block a region while you can't do anything else, because if you want to have a true geo test, you have to make sure that nothing else moves. So there's a lot of caveats coming with that you have to be careful. In the end, yes, the shorter the better, that's for sure. But sometimes you have to pick longer. The shorter the better, but you still have to have long enough. So shorter doesn't mean short, it means short. So experiment budget here is 5K. So the way I computed that 5K is I went into my geo data. Let's go back there. I see that we spend in total 150 over 3 months, so that's 50K a month. And I was like, okay, ballpark, we're going to test on something that will ballpark be half the country, so that's 25K. I thought, okay, 20%, additional 20% makes sense. So it's really a rule of thumb, but in the end, it's not just what is set in stone, is what you define as a maximum budget experiment. You can put an alternative budget if you want to. You can also exclude a few weeks here if you want to. As I explained before, if something happened or so on, sometimes it's good to exclude. Okay, so now we're going to run this. Okay. What do we have? All right. So what do we have here? So we have the design of a lot of possibilities of group. So we use greedy search. Greedy search is far from perfect. So the reason why greedy search is far from perfect is because it's going to use the time frame, and then it's going to look at what is the one that has the smallest noise group. And so it's really going to run all the possibilities and say, hey, okay, this split has the smallest noise. Problem with that is like you have a massive overfit. Usually when you do that and you plot the noise, you'll see that the noise is very, very, very narrow during the period you use to run the greedy search, and then just after the last day, it blows up. So that's a bit of the problem of the greedy search, is like there's definitely an overfitting in what we do. Here the R-square holder, what it does is that it split the periods that we use for the greedy search in half, and then you use the first period of the control and see if it's pretty well the treatment. So it really helps to see that there is a strong relationship between the two, and that we're just like not force fitting to reduce noise only. And above 80%, it's a proper good fit for that kind of test. Yeah, so everything above 80, even 75, honestly, like it's normal to have an R-square that is like not 99, because we're not predicting, we're just trying to find two groups that has a relationship together. And so here what we have is that we have a group suggested group. So we have those numbers in the treatment and then those geos in the control. Okay, now we're going to run this. And what it says is that with our minimum ROAS, we need actually a budget of 1K, even if we say 5K. Now, that's the minimum detectable lift and the budget that we need for that. So the caveat is that doesn't mean that you only need 1K. The caveat is that mathematically, in theory, if you spend 1K on your experiment, you should be able to see a lift. So there's a lot of caveats there. So 100% use that as a guideline to understand if, for example, you don't need to have like a ridiculous budget to be able to detect a lift, but always consider spending more than the minimum budget the model suggests. And one way you can actually improve that is, for example, one thing I love to do in Geo Test is, because I have a lot of clients who, for example, they don't have additional budget for tests. So I said, okay, that's fine. We decrease by 20% one group, we increase by 20% the other group. So you create a delta of 40%, which is absolutely massive. And the great thing about this is that, one, you don't need an extra spend, but it's always not 20-20, because sometimes one group can be bigger than the other one, but you get the gist. And also, it means that you have 3 points on your diminishing return curve, because you can observe what happens once you decrease, you can observe what happens when you increase. And so, although not perfect because it's by region, but you'll have those like decrease, normal, increase, and you have your diminishing return curve, which is absolutely amazing and which is often missing in a geo test, because a geo test you often come up with a spend, a number, you have an ROI, yes, but you don't know where you are in your curve. So that is one way to solve the problem. But yes, never ever just think that you only need that number that's coming here. I said 5K as a ballpark. I would 10% is usually good. Here, what it says is that we are way above that, so we should be fine. So you select the design you want. The dark green is usually the one you want to pick. And here you can see some data. So you have the response. You have the response data. Control versus experiment. You have the relationship between the two. You see that they're highly correlated. So obviously, this is also why the budget is so low. It's because the budget required is so low, is because there's such a strong relationship between the control and the treatment here with a demo data that just a little change will make a massive change. Okay. And so this is a summary. So we have in total 10 geos, but we are going to have 6 geos in the treatment, 3 geos in the control. And then if you run this, it's going to save your document and you'll have the list of the geos. Okay, so that's it. You run the geos, and imagine we are 4 weeks later and you want to run the result. Then you move into the TRBR post-analysis Colab. And so what you're going to do, very simply, you're going to put the spreadsheet where you have all the data. So that means all the data of the pre, all the data of the period, and then all the data of the cooldown. So yes, you're not 4 weeks later, you're a bit more than that. Ballpark usually 1 or 2 weeks of cooling down, depending on your consideration journey, should be enough. So we're going to run the first sheet. It's installing everything again. Okay, and then so here you insert the date. It's a demo. If you use the same sheets, you don't need to change anything here. But what it says that you had a pre-test of a month before, and then the start test, and then the cooldown ends. So here we have a week of 3 weeks of cooling down. Okay, and we press play, and so what it sees is that so you have the pre-test, and then you have the test, treatment, control. You see that there's an additional cost here. And then you can visualize the data. So what we do see here on the response side, which is like revenue, you see that the revenue increased during the test and then went back down against the treatment. And then you have the ad spend. So what we see in that specific test, which is slightly different than the one we use in the creation of the Geo test, is that they're only spending during that test period of time. It's not like a pushing or decreasing. It's really just like, let's try something for 4 weeks. And then if you run the code a bit lower, so you have your confidence level, you have your lower bound and upper bound. So it gives, here it's very narrow, right? So the estimate is at an error of 2.8. And then the lower bound, it says that it should be between 6.3 and 3.9. Now, it's a distribution, right? So it's much more likely that it's going to be the estimate than the bands, because the distribution goes like this, right? So, and the likeliness depending on the height of the band. So it's incorrect to say, oh, it's between 2.60 and 3.9. Well, it is correct, but it doesn't mean that there is an equal probability that it's going to be 2.8 or 263 or 3.9. That is not correct. So incremental cost 50, incremental response 443, which is 50 times 2.8. All makes sense. And then incremental response as a treatment response. So that's the incremental. And so you visualization of the result. You have the observe versus the counterfactual, you have the pointwise difference, so really like when we change the things, and then you have that cumulative cumulative effect here. And then you see that the cumulative obviously is not increasing anymore after we stop spending. All in all, it's a great first tool. There's a few caveats, but it can already help you really to have a first gist of how Geo Test work. I'll make sure I share my notebooks in the slide. But yeah, obviously you can go on the GitHub also and click on the link. I invite you to have a try. I can also share with you the demo data, so you can have a try yourself without bothering. But honestly, like, you can just like go on ChatGPT and say, give me 90 days with 10 geos with that kind of spend and that revenue, and then you'll be able to create your own demo data too. I hope you enjoyed it, and see you later. Bye.